Hello everyone, welcome to my channel. Today in this video I am going to solve this system of congruences. So this system of congruences can be solved using Chinese remainder theorem. But before we use Chinese remainder theorem, we have to simplify each of these congruences. Notice that it is of the form ax congruent to b modulo m, but I have to make it into the form x congruent to b modulo m. So for that I have to add the multiple of that m so that I can cancel it out. Let me show it. For example, 2x congruent to 1 modulo m, if I add 5 to it, 5 is a multiple of 5 obviously, so that comes out to be 2x congruent to 6 modulo m. Now I can divide both sides by 2. Notice that the GCD of 2 and 5 is 1, so I can easily divide it, so it will come out to be x congruent to 3 modulo 5. So that is after I have simplified my first congruence. Now second one can be simplified by directly dividing the both sides by 3, but I have to notice that the GCD of 3 and 6 is also 3, so I have to divide 6 also by 3, so it comes out to be x congruent to 3 modulo 2, and I can also write it as x congruent to 1 modulo 2. So that is after simplifying the second congruence. Now the third congruence can be simplified by adding 7, and when I add 7 I get a multiple of 4, and after this I can easily divide it by 4 to get x congruent to 2 modulo 7. Now 5x congruent to 9 modulo 11, I have to add 11 on both sides, then I get a multiple of 5 here, that is 20. So when I divide it, then I will get x congruent to 4 modulo 11. Now I have finally got my 4 congruence relation. So after I will apply Chinese remainder theorem here. So let me briefly state it. So x is congruent to the product of all the remainders except 1, and we have to do the summation of it, and it will be in the modulo of the LCM of the remainders. Let me illustrate it. For example, in this case x will be congruent to x1 into 2 into 5 2 into 7 into 11. Notice that I have not included 5 here. If I consider my first congruence relation, then I have written x1 corresponding to that, but I have not included 5. It is x congruent to 3 modulo 5, but in the first expression I have not included 5. Similarly, in the second expression I have not included 2. In the third expression I have not included 7, and in the fourth expression I have not included 11. And the modulo will be the product of all the divisors, that is, here it is 5, 12, 7 and 11. So now when I will take mod 5, then notice that the product in which x2 is present, x3 is present and x4 are present, all the 3 will be eliminated because 5 is already present here. So what I will be left with is 3 congruent to x1 into 154 mod 5, and when I will simplify it, I will get x1 congruent to minus 3. So let me substitute that. Similarly, I will take mod 2, and in this case also many terms will get cancelled, and x2 I will get as 1. I will substitute that back here. Then I will take mod 7. In this case also many terms will be cancelled, and I will get x3 equal to minus 1. I will substitute that. Then I will take mod 11. Then many terms will be cancelled, and I will get x4 equal to 1. So finally I have got my expression. I will simplify this to get x congruent to 653 mod 770, and that is our required answer. Thank you for watching this video.